Okay, as you can see, this is where we left off with last time. And one of the things that when it comes to lipids, we know, yes, they are fats, because fats are, of course, this. And I would be led to believe this is perhaps probably the best type of oil that you can use. But perhaps the problem with that for people might be what if you want to use olive oil all the time. It's not that it's unhealthy. Once you go to the grocery store, you find the olive oil. It's perhaps a little more expensive than the other two that we see here. And I guess I don't know why. I'm guessing it's just the processing portion of that. As far as, I don't even know where olives grow. I don't even think they're a domestic product. Maybe they are. I'd be on the impression that they're imported, I guess. But regardless, I like to use olive oil as often as we can, but like you had mentioned, it's a little more expensive. Okay. So this is, again, an introduction, and this was at the very beginning of the chapter where it says an introduction, and that would be on page 565. Okay. So, might be asking yourself, if this is so unhealthy, why do we include that in our diet? Well, I guess you could say that that's a good question. Probably the biggest aspect is going to deal with your metabolism, okay? And especially when we're talking about cholesterol, of course, because it used to be that we thought cholesterol was unhealthy for us, but no, that is not the case. If and when you have a blood test taken, like we were talking yesterday, probably when you get into your 30s, maybe, if you choose to have an annual physical, which I think is a smart decision to make. And with that, when they do that blood test, maybe they are testing your cholesterol level and your lipid panel, which would include what we call HDL and LDL, which means high density lipids and low density lipids. And it's one of those aspects when you see the results, you want the high density levels to be just that high. It's the low density lipids that are unhealthy for us. And we'll get into that later on when perhaps when we start talking about vitamin metabolism. So whether it's dealing with metabolism or just regular cell maintenance, having these in our diet is certainly essential for regular cellular function. And one of the things that we will talk about is, perhaps it's a little unfair now because all the eyes are going on yourself when we talk about amino acids as far as what we had done in anatomy and physiology. Okay, as far as our diet is concerned, you have essential amino acids and non-essential amino acids. You have the same thing or something very similar when it comes to that of lipids. There's those that are essential lipids and those that are non-essential. So, as far as what your diet is concerned, just like with amino acids, what would possibly be the difference between essential amino acids and essential lipids and non-essential lipids? So which one do we take in through our diet, would you believe? The non-essential or the essential ones? It's kind of a tricky aspect, and maybe it makes more sense once we... You need the essential lipids is what you take in from your diet. Is it non-essential? No, it's not that important because your body can metabolize that. Same thing with that of amino acids within our diet. Okay. So again, lipids have a function in any one of these, whether it's the sex hormones, progesterone, testosterone, estrogen, any one of those. They act as chemical messengers because we know, for those of you who have had anatomy and physiology, that hormones are certainly responsible for triggering different types of chemical reactions within the body. Now, when we refer to these vitamins that are both that water soluble and fat soluble, okay, one of those that we'll talk about at a later time, I do believe that's not up here, certainly is vitamin C. When we look at these, okay, if it is water soluble, in your estimation, is it okay to have water-soluble vitamins in excess?
Yes.
That is correct, but why are you right?
The water can break them down.
Oh, it's not so much that the water will break them down. I mean, you're not that far off. What that means then is it can be filtered. Where in the body would you think? Yeah, exactly. The kidneys can filter those vitamins out. Should it be one of those aspects to where, okay, I'm just speaking in, what is it, maybe third person, I'm speaking for someone else, where they're saying, I'm a health conscious person, I need to feel like I gotta have my vitamins and nutrients and take them to excess. What happens is if you do that with vitamins that are water soluble, that is okay, because if that is the case, they can be filtered through the kidneys. It's these that are fat soluble, which means if you take them in excess, just like sugar, okay, if you have excess sugar in your blood, you're not going to be able to get rid of all that. You're going to store that in one of two ways. It's either going to be converted to glycogen to lower your blood sugar levels, and then eventually maybe stored as this. And that's the problem. If you take something to excess that is fat soluble, it will be stored in your body. And some of these vitamins that are fat soluble is not a good idea to have in excess. And we'll talk about that at a later time. Okay? Again, I'm going to pick on yourself. Okay? Or should we wait till the rest of your clan is back? Yeah. Okay. You feel like all the pressure's on yourself. Okay. Because it deals with this right here, the anatomy and physiology of where this is, where it comes from, and everything else. It's been over a year.
I remember it, I just don't.
Don't remember the slight details? Okay. All right. So I see we're up to about 10 minutes. There's just a couple things that I want to go over on the board. As far as this is concerned, we will pick up with this tomorrow, okay? And then, because that's where we're actually starting the new section. This is, as you can see, is just the introduction. It's an overview. Then here's where we really start talking about, you could say, the nuts and bolts, because we're going to put an example of something like these up on the board, and it's based off of prior knowledge that will make sense. Oh, geez, that buzzing noise, I thought that was the bus coming back. Okay. So one of the aspects, okay, I think you can see this on the board over here. We want you to be able to draw, okay, these fatty acids: lauric acid, mysteric acid, palmitic acid, and stearic acid, okay? Then the bottom ones here is just for a matching purpose. So you'll see the formula for palmitic acid, oleic acid, linoleic acid, and linolenic acid. I believe that's how they are pronounced, okay? Now, these have very, let's say, specific breakdowns to them. I don't know if that's quite the right word, but with these, okay, these are called saturated fats, okay? Then we have these two, which are unsaturated. Unsaturated, what would you believe? Unsaturated fats. Then these bottom two are what we call polyunsaturated. Now, as you're looking at that, it's probably like, oh my gosh, look at this new content. It's saying these terms: saturated, unsaturated, polyunsaturated. Oh my gosh, where's this coming from? Okay? We can use prior knowledge to sort this content out. And what I mean by that is we'll just, you go ahead and pick any one of these in the purple. Okay? So what that means then, I believe, okay, this, we've never drawn compounds like this before, but it'll make sense on why it is that we do this, okay? It's more so of a molecular formula, because these compounds are just so big that it would take a long time to write this chain out, okay? So what I mean by that, I believe it's this, and then, okay, don't get too far with that. Let me just double check that, because we said lauric acid. Yes, that is correct, okay? So we haven't seen compounds like this before, okay? Because we've never drawn them out. But you can certainly appreciate and see why you want to draw these like this. Because if we were drawing something like the hexanoic acid, well then what you would do, of course, is this. So we're basing all this off of prior knowledge, and what you could do to condense that down is say, okay, CH3, okay, then how many CH2 groups do you have? Okay, so then you'd have 4, and then COOH, okay? And this table that we're talking about is table 19.1 on page 567 is where you can find this content on there. So it's kind of like a new spin on old knowledge, because if we were to write the structural formula for this out, as you can see, it's not so bad writing this 4 times. Okay? This is still the component for hexanoic acid. But once you get up to lauric acid, you'd have to write this out 10 times. You're going to be all the way over here. Okay? So it just makes more sense, and I think you would agree this is a lot better way of looking at it, even though it's new content. Okay? So as we see, this is a saturated fat. Okay? Where is another time we possibly saw something like saturated and unsaturated? where does that term maybe sound familiar? You got to go all the way back to August and September. Long time ago, I know. Well, just think about when someone asks you questions. Well, do you remember that 30 years ago? Yeah. So how or why might that sound familiar? Saturated and unsaturated. You are so close when you say polycarbons, okay? So what we can do is say something like this. Okay, you would agree that's probably all the way back to August and September. Simple butane. Okay? How is butene different than butane? Right, it's got a double bond, so therefore, not only is this an alkane and that's an alkene, which one of those is saturated? Yeah, this is a saturated hydrocarbon. So what we refer to this then is a saturated fat, because when you draw all that out, all those carbon-to-carbon bonds are what type? Single or double? Yeah, they're single because they are saturated. So it's just like what we would see here. So then what happens is, how would you guess that that an unsaturated fat would be different from a saturated fat? Okay, you got to be a little more specific when you say it's not full. You're not wrong, but you're not right either. It does. Yeah, there's a double bond in there. So when you say it's not full, yeah, that's what we'd say perhaps half right. So these compounds get to be quite large. So with that, I'm just going to draw this up here, because remember, for these, you're just matching them. You're not going to write out a structural formula like this. We just want you to be able to recognize that. So in this case, we have got, I think that's right. Okay. Now, this might be a little confusing, and I'll elaborate on that in just a moment. Okay. So when I say that that probably looks a little confusing, I would probably agree until you have a really good understanding of this. And like you said earlier, it's unsaturated because there's a double bond in there. So what that means then, what you can do, rather than writing CH double bond and CH double bond, go back to what you're familiar with, and that is this. We're not taking that double bond out. I maybe should have used this black marker, but I think it's showing up okay. Is that you have this carbon here, and then remember it said CH and CH. If you're more comfortable doing that, now, be careful when you're doing this, okay? Because it's a very, very specific difference. What, in your estimation, do you think happens if you do that? Now we're going back to late September, maybe into early October. Right, because these compounds are all in the cis formation. Because when you do this, you're saying this is a trans fat. This is not a trans fat. If you want to write it like that, make sure, at least to my understanding right now, make sure you write them like that. Or how many of you are just comfortable doing this anyway? The reason that you would say that this makes no sense to me is hydrogen cannot double bond. But yes, we understand that, but that's not what we're saying. The double bond is actually between the carbons. Okay? We're up to 20 minutes, and I think that's probably enough. So the big thing is just being able to recognize the difference between saturated, unsaturated fats, and then what would a polyunsaturated fat look like? Nope, not triple. I think you're right, but I didn't quite hear it. Multiple double bonds. Rather than having one, you're going to have more of those double bonds, and that's why it's a polyunsaturated fat. We'll catch up with that, and like other class mates in high school, tune in next time for maybe more fun. Tune in next time.